So I'm going to start with a function f of x equals x squared. But I'll also enter my formula into Desmos, and then we can see what it looks like as it's being transformed. I'm going to do a vertical shift 2 units up. You can create a new function, g of x, by taking your original f of x and then adding some constant to the end of the formula. This would be a vertical shift. So for my formula, I'm going to take x squared and add 2. That's going to be my transformed function. So let's try it in Desmos. So I could start with f of x equals x squared. That's the original function. It's a parabola. And now I'll create a new function by doing x squared plus 2. So now it's shifted vertically. Okay, next I'm going to shift horizontally by 4 units to the, let's say, left. Now when you're doing a horizontal shift, the rule would be that you take the original function and you have to make the shift directly to the x variable. And this will shift it h units to the right. I don't want to shift mine to the right, I want to shift it to the left. And so I wouldn't use a subtraction, I'll use an addition instead on my problem. But what I have to do is I have to take my original, I have to write open parentheses where the variable x used to be in the formula. And so what I do is I replace that x now, and I'll do x plus 4. What this will allow me to do is shift my entire parabola by 4 units. I'm going to be going to the left though, because I had used plus instead of minus. It's always the opposite of what you'd think for horizontal shifts. If you do minus, you move to the right. If you do plus, you move to the left. Let's try it in Desmos. There we go. The green represents my function, which has been shifted twice. I moved it up 2 units and then to the left 4 units. Now we can do what's called a stretch or compression. I'm going to stretch my function vertically by a factor of 2. What you need is you need the new function g of x to equal k times f of x, where k is just some constant being multiplied by the outside of the function. In my case, my factor is going to be 2. So I want to multiply every value in my function by 2. Typically, the easiest way to do this is to rewrite your original exactly as it is, then put parentheses around your original like this, and then put that factor that you want to multiply by on the outside. If you want a compression, you need a factor that's less than 1. If you want a stretch, you need a factor greater than 1. Alright, so let's try this on Desmos. That's just the original. Now I put a 2 on the outside. So what's happening is every point that's on the function previously will be moved twice as far away from the x-axis as it was. And so that would be considered what's called a stretch. If we had done a compression, we could have done, say, 1/2. And now what we're doing is we're flattening it out, so like the smaller the factor, the more you squeeze it. But we want to stretch. Alright, now we can also stretch and compress these things horizontally. So if we want that, I'm going to say I'll stretch horizontally by a factor of 2. Alright, so that one's a little bit tougher to do, a horizontal stretch. You have to apply the stretch directly to the x variable. Alright, so if we're doing a horizontal stretch, we'll do g of x equals f of k times x. So there has to be some number k which gets multiplied by x. But the funny thing about the horizontal stretch is, just like horizontal shift, it's the opposite of what you'd think. So if I take my original function that I was working with here, I rewrite it, I gotta put some number in there directly multiplied by the x. So what number should I put? You might think it would be 2, but it's actually not 2, because if we do that, we don't get what's called a stretch. It would be a compression. A compression means you're moving your function like closer to the axis. So the larger the thing I multiply by, the more squished it's becoming. See, it's getting flattened toward the y-axis. But we don't want that. We want it stretched horizontally instead. So what you do is put a 1/2. And now you can see the black there is more spread out than it was before. Alright, so you have to do 1 over whatever the factor is that you want to stretch by. Okay, next we might want a reflection. So I'm going to say reflect vertically. Alright, for that, all we have to do is take the original function and put a negative on it. But the negative has to go on the whole thing. So if I start with my function that I had in the previous step, I have to put the negative on the outside of the whole thing. And there we go. We can see that it took the black parabola from the previous step, and it took every point that was above the x-axis and flipped it to be in its mirror image below the x-axis. So that's a vertical reflection, it's called. And now I'll reflect it horizontally as well. Okay, so for that we follow the rule of g of x will equal f of negative x. So the negative has to go just on the x alone, not anything else. So I would take my function that I had in the previous step, and I'm going to take that x and replace it now. Replace it with a negative x. And if this works, it'll reflect our function across the y-axis now. There we go.